So we are modeling with linear functions.
It's not. My hair's not that long.
You're recording on YouTube.
I don't care. Hi, YouTube.
So we have our shoe length and height data from the entire class, and we've graphed it. Okay. When you get a bunch of data like this, usually we're going to use a computer to analyze it or a calculator. Okay. But I'm going to show you how to do it by hand and with the calculator. So you need to be able to do both. Okay. Just a couple notes on graphs. Do you see anything that's missing on this one? Stop it. Yeah, we haven't labeled it. Okay. So what's the title that you use?
Modeling.
Yeah, what title would you put here?
Correlation between shoe length and height.
Okay. What is the y-axis, since I left myself enough room? Height. And what are the units? Okay. And then the x is shoe length. And that's also, okay. So now this is a nice pretty graph. You're going to earn a 4 for that, okay? Make sure you put a break here if you need to. Okay, if you put, make sure your scale's appropriate. But if you jump from 0 to 10, put a break. Okay, okay, sounds like you're well versed there. All right. Does this look like a general trend in the upward direction that's linear? General.
Yeah.
Like I said, this is an inexact science, right?
Oh.
Is it kind of linear in trajectory?
Yes.
It is. Okay. And when I say linear, we're going to study data that looks exponential. We're going to study data that looks sinusoidal. Okay, we're going to study quadratics. So we're going to model data with all these different functions. For now, it's just linear, of course. What?
Did you count the manifest difference part?
That's what we're headed towards. So the question is, can we come up with an equation to model this in general? Right? Since you're all experts at writing linear equations now, right? The only trick is to draw your line appropriately. So, yeah, just does that look like a pretty good general trend? Okay. By hand, it's not an exact science. Okay. Here's a dot, and there's a dot. What 2 points are those? Brandon Milius. Which one was that? This one?
I think you know that.
Which one is this?
10 and 63.
And then we generate an equation from that, right? Okay, go ahead and write that equation, since you know how to do it, right? Anybody got it? Nope. Okay. equation? Anybody? You don't know what's right? You don't like it? What's the slope?
9/325.
That is pretty ugly. Is that, did anybody get a decimal like 2 point something?
2.7. 2.8.
2.8 is good enough in this case. Now we can do point slope, right? Easiest version. It's a little bit more useful if we do a slope intercept, just because it tells us the y-intercept. Okay, so if we were to convert this, so we got negative 28 plus 63.5.
It's 63. Oh, no, never mind. Oh,
Scared me there for a sec. So is that right? Hope it is. Okay, so part of what you want to be able to do with this data is analyze it in context. Okay, so what does this mean?
Every 2.8 plus the 2, you increase 35 inches in height.
2 inches a shoe gives us an inch of height.
No. The other way.
Okay, there you go. So for every 2 inches of height, 1 inch of shoe length is gained, right? You could also say 2.8 inches per inch, or there are lots of ways you could say that, but be able to interpret that. Okay. What does this mean?
That's where you started.
Yeah. It is where we start, but what does it mean in context of this problem?
That's like, that's
That's a height at which you start.
This is a y-intercept, right? So what's the y variable? It's height.
a height.
So it's the height at which shoe length is what? And it doesn't make much sense. 0.
No.
Does that make sense? No. The y-intercept's where we're going to get some funny data. All right. So if you're 35.5 inches tall, you don't have any feet. Congratulations. Okay, so be able to interpret these in context of the problem. Okay, you'll get some practice at it. But those of you headed into psychology careers or any social sciences career, it's a big deal to be able to interpret mathematical data. Okay. And science too. Science is a big deal. All right, are we good with that? Okay, so that's about as far as we can go by hand. No, that's as far as I want to show you that we can go by hand. If we want to calculate a correlation coefficient, we can take up pages and pages. But okay, so the other step is to do it in the calculator. So if you don't have one, you'll get one. This is where we get a little bit more exact, but it's still not quite perfect. And this is where a lot of people get lost. It's just the process of putting it in the calculator. Have you seen this?
Yeah.
Some of you? Math 3? Yeah. So please follow. Okay, so we're going to enter this data in our lists. Okay, so we need to go to Stat and Edit. So it's stat enter. If, sorry,
Bless you.
try not to. Sitting in a tree stand last night, and I'm like, trying not to cough and sneeze, it's terrible. If you need to clear the list, you highlight the number and hit clear enter, and it gets it done. Or you can just go delete, delete, delete. And if you have a really long list, you can sit there for a while. But we want to work in list 1 and 2, if possible. And enter your data. So just start typing the shoe length in L1 and the height in L2. So 13 and a half, enter, 11, enter. This is where data entry gets kind of tedious, to be honest with you. And the nice thing about tech nowadays is it usually will actually gather the data for you. So this step, or if you're high enough on the totem pole, somebody else gets to do this for you. And please don't skip any numbers, because that screws things up. Just 67 or 69?
69.
69 there. Make sure your lists are the same size. If not, you'll get an error. It won't calculate anything. So you might as well check at this point. If you've made an error, you need to find it. Have fun with that. Good? About. You realize we're almost done. We have about 6 minutes. Okay.
What did I use? Mike screwed everything up.
What's new?
Hey.
Okay, so we got our data. If you need to cut it off, you can. Just delete the extra data. Your next step is to go to the stat menu again. So everything is in statistics here, stat. We're going to calculate this time. And we want linear regression. Linear regression is what it's called when we do it here. Linreg. Enter. Everybody with me still? Stat, calc, linreg. We are in list 1 and 2. We just need to go down to calculate, hit enter. And you get your calculator equation. Okay. 3.43x equals 26. Okay, we should all have the same equation. If not, somebody typed wrong. Me or you.
You. It was you.
If all of yours agree, then it was me. Fine, whatever.
3.1.
Okay.
Me and James got the same thing.
Let's tell you. Okay, so what do we notice here? A little bit different, right? A little bit different. Y-intercept is a little bit different. This is steeper, right? So 3.43 inches per inch of height. On your calculator, is there an R and an R squared?
No.
No.
Some of you know yes. Okay, we can fix that. Don't have time today, but this is what's called a correlation coefficient. Okay. We want it to be as close to 1 or -1 as possible. So we're kind of like moderately strong here. I'll go over all these words tomorrow. But we want this to be as close to 1 as possible. What would a shotgun blast be? 0.
0.
Yeah, it'd be like 0 everywhere. Okay, so you can do that on the calculator. Any questions? What?
Are you? No.
Okay, 4 through 11, because these problems are a little more involved. And then I want you to pick one from 14 through 19. There are some applications there in medicine and engineering, and pick one of these, just one. I don't care which one it is. And have a nice day. And wash your hands. Put your calculators back to you.